Okay, now we will select our viscous models and assign boundary conditions to our project. In general tab you have solver types. Here we select pressure based and time as steady. We will not do transient analysis, we will do steady analysis. So after that select your viscous models. The viscous models, you should know about these things. They are turbulence models, and as our flow will be turbulent, so we have to select one of these ones, and each and every model is appropriate for certain flow conditions. And the SA model, spell out Elmaros model, is a one equation model for such type of flows as external aerodynamics. The SA model and K omega and SST K omega models are appropriate. The most appropriate is SST K omega model, but it takes little more time than SA model. So for example, we select the spell out Elmaros model and keep these as default. We click OK. Now material, you should select fluid is air, that it is, and solid is aluminum by default. You can change it from to any other material if you like. Similarly, in the boundary conditions, as we have given we have specified names to our each surface. Now they have been loaded over here. The core body is a stationary wall and with no slip condition. So it means that if you give appropriate names to your surfaces, Fluent will automatically recognize them as appropriate. You can change the roughness constant and all these things according to your requirements. Pressure outlet, we have a zero pressure outlet, and velocity inlet, here you can give the speed of your velocity. For example, if we select magnitude normal to boundary and more magnitude, velocity magnitude is 22 meter per second. Click OK. Symmetries, if you give them name as symmetry, it will automatically recognize it as symmetry, and you don't need to change it over here. Okay, after that we don't have any dynamic mesh. Reference values, this is important one. It means that it will select that area of your core model for drag and lift calculations. So compute from velocity inlet area, here it has taken by default as 1 meter square. You have to change it. You should calculate your frontal area, and you can also calculate it from here in the reports. Projected areas, it is in X, as you can see, or velocity will be in the X direction. It will face the frontal area of our car. So we select a car body over here and compute. It takes 1.1175 meter square. So this is our frontal area. We will paste this over here. Similarly, as we selected compute from velocity inlet, it has automatically imported our boundary condition that we have assigned at velocity inlet as 22 meter per second. So it's done. Okay, now the next thing is solution methods. These are certain discretization schemes. You should read about all these and how they have effect or how they affect our solution. So the most simple one is known as also simple semi-implicit method for pressure linked equations. It has certain modifications is simplex P. So the most appropriate is coupled. It takes more time, but it converges the solution more quickly. It also uh, captures a lot of memory. So if you have more RAM, you can select coupled or you can stick to simple. After that, you have to select the special discretization schemes for pressure, momentum and terminal viscosity. So if you want to do second order appointment, that's accurate. Same is the way that it will take more time and more memory, but it converges the solution more quickly. If you use first order appointment, it is a more light one, but it will take more iterations to converge the solution. So similar is the case for this. After that, you should check your solution controls. These are under relaxation factors, and you should also study about them, that how they affect your solution. Next thing is monitors, convergence monitors. Here by default we have only residuals, so it calculates the residual and you specify certain convergence criteria. Here it is 0.001. It means that if your residuals fall to 0.001, it will converge your solution. So if you don't want to have a convergence criteria and you want to manually check your values from here in the table, then you can also select none. Okay, now we create our force monitors for drag and lift. We want to plot it, and we want to calculate drag on our car body.